Okay, Assalamualaikum. Today I'm going to explain to you about Newmark's and Fadum's chart special for you for week with the wall. So this is how we determine increment of vertical stress due to uniform loaded rectangular area. As you can see here, this is a rectangular foundation. So we have the longer side as L, the shorter side we consider as B, and Z is the vertical distance from the bottom of the foundation to the point of interest. So in this case, A is the point of interest. And the increment of vertical stress is equal to QIR. Q is the load from the foundation in kilopascal or in kilonewton per meter squared, and IR is from either you use the table or you use Newmark's chart or you use Fadum's chart. So it's up to you, or it depends on the question given to you. Okay. So then sorry. This is an example of table for influence factor IR. Yeah, IR. R stands for rectangular. So you have to know what is L, what is Z, and what is B. So because you have to determine IR based on L over Z and B over Z. Okay, so the top one is L over Z, and the vertical side is left. Left vertical is B over Z. So let's say if your L over Z is 0.2 and B over Z is 0.2 as well, so your IR would be 0.0179. So let's say you have Q equal to 100 kPa and your IR is 0.0179, so your increment of vertical stress would be 100 times 0.0179. Okay, next. So here you can see Newmark's chart and Fadum's chart. So Newmark's chart, it's like a spider web. So this Fadum's chart, you can see curved lines with the X axis as L over Z and Y axis for the influence factor IR. So the curved lines represent B over Z. Okay, so the x-axis represent L over Z. So let's say if your L over Z is equal to 1 and your B over Z is equal to 0.1, so you just follow the curved line 0.1, go to the x-axis 1, so your IR would be between 0.02 and 0.04. So you may take it as a 0.03 for your IR. Okay, another example, if your L over Z equals to 1 and your B over Z equals to 0.3, you just follow the curved lines. Okay, so now your IR is 0.08. Okay, so then this Newmark chart is a special. Right, Newmark's chart has a specialty which that you have to plot your foundation plan or layout on a chart itself. So the chart is normally just in the size of A4 paper. So you have to scale down your foundation size, which your original foundation size normally in meter. So you have to scale down to cm. Okay, so how to scale down your cm? You have to use better scale, which is come up from your Z tab, and also line AB that found in your Newmark chart. So you have to check what is your line AB measurement. So you have to measure line AB, and you have to know the depth of the point of interest that you want to determine. Okay, so let's say, okay, here for this Newmark chart, as you can see the line AB there. So you have to measure your line AB with your ruler. So let's say your line AB is 2 cm. So you have to make it equal to your Z. Okay, let's say your Z is 5 meter. Okay, so this line AB, which is 2 cm, you must make it equal to your Z 5 meter. So means that your scale now is 2 cm is equal to 5 meter. So now you can scale down your size of foundation from 5 meter side and 3 meter side to smaller size in cm. So then you can plot your foundation layout. Okay, so it depends on your depth. Okay, Z. If your Z is equal to 10 meter, so your AB will be 2 cm and your Z is 10 meters. So you can get that range, the scale. So then you can draw your layout in a smaller size on your A4 paper on your Newmark chart. Okay, so like AB, you have to measure with your ruler to get the better scale. Okay, so that is how you sketch or you draw your foundation plan layout on the Newmark chart. So others specialty of this chart that you have to plot your point of interest at the center of the chart. So as you can see the website, the spider web, this chart. Okay, this chart is a Newmark chart. So your point of interest, let's say case A. A is located at the center of the foundation. So the point A must be at the center of the chart. And then you draw your layout so you can get your. So, okay, now B at the corner of the foundation. So you have to make sure that point B at the center of the Newmark chart. So after you draw the plan, so you can get the point B at the corner of the foundation. Okay. Same goes to point C. So you can see here point C is 1.5 meter away from the foundation. So you have to plot the point C at the center of the Newmark chart, and your foundation layout plan away from the center of the Newmark chart. That is how you plot uh, your foundation layout. Okay, next step. Okay, first is Z, second is the scale, third is the point of interest at the center of the foundation, fourth you have to count number of squares that the plan layout covers. Okay, so you have to count how many squares, 43, 42, 45, whatever, complete squares. Okay, for sorry, I'm not well today. Okay, so that is an incomplete. There are few incomplete squares, so you can combine it to become a one complete square. So you have to count how many squares. Okay, like this. One, sorry, two, three, four, five, and so on. Okay, that's how you use a Newmark chart. Very easy. Okay, the fifth is you have to know the influence value stated on your Newmark chart. I'm so sorry. So the influence value of your Newmark chart will be stated on your Newmark chart. So that will be IQ. So if you know your Q is 100 kPa, your number of squares 43, let's say, and IQ is 0.005. So finally, you can get the increment of the vertical stress at the point of interest. Okay. Right. That's easy. Alright, next. Okay, Fadum's chart. For Fadum's chart, you must make sure that the point of interest at the corner of your rectangular foundation. Okay, same. The shorter side is B and the longer side is F. So the point of interest is the one that you want to determine the increment of the vertical stress. So it must be at the corner of the rectangle. So you have B, you have L, because you need to determine B, uh, L over Z and B over Z. Okay, to get the IR from the Fadum's chart. Okay. So B over Z and is equal to L over Z. So from your Fadum's chart, your x-axis is L over Z, a curved line is MB over Z. So from that Fadum's chart, you can get the IR value. Okay, so it's very easy to read this chart. You don't have to draw, but you have to read from the curved line and the x-axis. So y-axis is the IR. Okay, because of your the rules in the Fadum's chart that the point of interest must be at the corner of your rectangle foundation. So if the point of interest is not at the position at the corner of the foundation, let's say at the center of the foundation, um, side of the foundation or away from the foundation, so you have to use principle of superposition. So in this example shown here, you have divide, let's say your point of interest at the center of your foundation, so you have to divide it into four smaller rectangle foundation. Okay, because to make it the point of interest at the center of sorry, not center, at the corner of the formation. So now instead of one big or one large rectangle foundation, so you have now four rectangle foundations. So number one, the corner is at the same as corner foundation 2, corner foundation 3, and corner of foundation 4. So you will get 4 increment of vertical stress. Okay, then you have to total up all of them. Okay, some of them. So you will get the total increment vertical stress at the point of interest, which is equal to from foundation 1, foundation 2, foundation 3, and foundation 4. Okay, alright. If your point of interest is at the side of your foundation, like this, so what you have to do is that you just divide it into 2, because you have to make sure that the point of interest at the corner of your foundation. So in this case, you just divide it into 2. So you have foundation 1 and foundation 2. So you get the increment of vertical stress due to foundation 1. So that point of interest at that corner. Okay. And for foundation 2, that is the corner, the point of interest at the corner. So you just total up. Okay, if in the case of your point of interest away from your rectangular foundation, okay, sorry for the interruption. Right, so you have to consider a large foundation to cover all the area. That will be foundation number 1, because you need that point of interest to be at the corner. Oh my god, at the corner of your foundation. Okay, and then if you see the foundation number 2, actually it's just imaginary. Okay, foundation number 2 is just an imaginary foundation, because actually the foundation is only uh, half of the area. Okay, oh my goodness. Okay, uh, okay, be back. All right. Okay, that is just, there's no foundation at the top of that ground surface. Okay, but you have to imagine that there is a foundation on that surface. So that's to deduct from the large foundation in number 1. Okay, so that's why you have to minus foundation number 1, because there is additional size of your foundation, and then minus with the imaginary foundation at the area where empty area is supposed to be empty area. Okay, so that's why you have to minus. If not, it's like overload. Okay, so over calculated. Yeah, something. Okay. Mhm. So this is uh example how to calculate your increment of vertical stress using Fadum's chart. Alright? Okay, hopefully you can understand my explanation, and you can try to solve problems which I already uploaded in your iDiscuss island. So enjoy solving the problems and see you next week. Okay, bye.